we come to the experimental part. Here is a multimeter. It can measure several kind of things like voltage, resistance, ampere, and they are combined in in 1 meter. So we call it multimeter. Then this is two test leads, positive one and the negative one. Just to control it. So now it's off gear. Since we're going to the part 1, the first table, which is we're going to read the color code of the resistor. So here, which is the resistor looks like. See the resistor here. The color here, 1, 2, 3, and the last color on the right hand side. So this is A, B, C, and D. First thing is that you're going to read the color code. Second thing is read the multimeter here. Then we choose the omega gear, measure the resistance. It doesn't matter the positive and negative. Then hold it. Wait for a while and read it on the multimeter. And here is the unit, omega, right? Then we come to R2. This is R2, A, B, C, and D. Okay, and we'll measure it now. Then let's read it. Come to R3. Okay, this is the resistance of R3. And come to R4. This is the resistance R4. Be careful now. Here the unit becomes to K omega, okay? Then we come to R5. This is R5 resistance, and also be careful, which is K omega here. So now we come to the second part of the experiment, which is we have 3 circuits: series circuit, parallel circuit, and the combined circuit. First of all, I would like to introduce this equipment to you. This is we call the breadboard, and they have a lot of hole on it. The point of this breadboard set, for this we have 1, 2, 3, 4, 5 part, and this one 1, 2, 3, 4, it looks like same, and this one is different. So today it mainly introduce these 4 parts to you. Okay? They are 4 same part. In each part, use this one as an example. They have 5 rows. 1, 2, 3, 4, 5. Okay. Then they have a lot of columns. So they are connected inside each columns. Okay. In this column, they are connected. Second column, they are connected, but between the different columns, they are disconnected. So in this case, we can set up the circuit for the series circuit in this way. So I just plug the resistor in. For example, I plug them in the same row. Okay, well, I said in the same row, they are disconnected. And I want this resistor connected with this resistor. How can I do? So I put the same fit, okay, same fit in column, okay. The column, they are connected, plug in. So these two resistors, they are connected now. Then we go to R3. So these two resistors connected, these two resistors connected. Totally R1, R2, R3, they are in a series circuit. So now this is R1 and R2 in series circuit. Then I measure the resistance of them. R1, this is R12. R12 resistance, which is this one, okay. Then we're going to measure R2 and 3. So we take, this is 1, 2, 3, okay. So we put the 2 and 3 in a series circuit. Then I measure it and hold on. Read this. Then read it. Okay. Read it. Finally, put them 3 into the same circuit. This is series circuit for R1, 2, 3. This is R1, 2, 3, okay? Then read the circuit, read the resistance, be careful, K omega, okay? So this is for circuit number 1. Next one, which is the parallel circuit. So in parallel, we only measure R1, 2, 3. Okay, R1, 2, 3. Then how to make the parallel circuit, which is put their feet into the same column. Okay, the column, they are connected. Okay, this side also, this column, same column, then they are paralleled. Okay, this is 1, 2, and 3. Let me make it bigger. Same column for this feet, and same column for this feet. This is parallel. Then we measure the resistance of them. Let's read it. They are okay. Now we go to the third circuit, series and parallel combined circuit. It is R1 first, R1 here, and R2, R3 is a parallel circuit. To be careful, this is R2 and this is R3, okay? In the same column. So please look at here. R1, the fit, one fit of R1 comes to here, have the same column with the other two resistors R2 and R3. So 1, 2, 3, they are in the same column. Okay. So in this way, they are combined circuit. R1, 2, and 3. in this circuit we're going to measure R23, which is here. Okay, so then for a while, then let's read. This is R23 from measurement. R23. Then come to R123. R123. Wait for a while. Okay, this is R123. Now we come to the final part 3, Kirchhoff's law. In this circuit, then we have 4 batteries. Each one is 1.5 volt, and 4 totally it is 6 volt. And it is positive and negative cable, positive cable. So let's set up it first. And from here, it is from R1 to R5 list. So R1, put in R1 connected with R2. So R1, R2, they are in the same column. After that is R3, because we cannot use the same part, so we choose another part of the on the breadboard. And then R4, 3 and 4, they are connected in a series circuit. 1 feet of 3 and 4 in the same column, 1 feet of 1 and 2 in the same column. After that, R5. R5 is point C, right? Point C. Okay, better. And point D. So, totally 1, 2, 3, 4, 5. And they are together. They are connected. This is point C, point D. In between the different parts on the breadboard, they are disconnected. Okay, so we should link this point and this point together by the wire. So we need to connect this column and this column together. Okay, so the wire in the same column with the feet, wire in the same column with the feet, this part as well. So this is the same column, same column. So here, this one is point A. Here is point B. Okay, because we use the electric wire to connect them together, so they are equipotential point. Then we have the battery. Put it on. So the battery comes to the A. This is point A. Okay, this is point A. And this is point B. Negative part connected with point B. This is our circuit, or figure 5. Okay. And you can see that here is a loop and here is a loop. So now we will measure the voltage first, because voltage is easier. Turn on the multimeter. Then voltage AC. So it means A to C. Then A is positive, C is negative. In this way, then you can read the number This is voltage AC. Then please read this number. After that is CD. This is CD. Voltage CD. After that it is DA. D and A. Read it please. DA. Okay, this is for loop 1. We come to loop 2. Voltage CB. Read it please. After that it is BD. So read it please. After that DC, which is this one. Please read it. So this is voltage of loop 1 and loop 2. Now we come to measure the ampere in this circuit. First of all, we're going to measure ampere of AC. This is A and C. So in this case, this point is A goes to R1, and we disconnect this resistor first and connect the multimeter in amperemeter inside, and this point is C. So this is AC. Let's read the number of the IAC, ampere AC. The unit here is milliampere. Okay. We'll put it back. We'll go to next one. CD. C here, D here. This is CICD. Next one is IDA. D is here, A is here. Okay, so we same D first, D A. Read the IDA here. ICB. C is here, B is here. So like what we did before, connect it. You can read the number here. This is ICB. It's IBD. This is B, here is D. From B to D. And this ampere. DC. Positive D, negative C. Okay, in this ampere, this is all in the table. Then we need to measure the I, capital I, total ampere in this circuit. So it means start from the battery, goes to this circuit, and the total amperes here. After that, we go to measure the capital V, total voltage of this circuit. So this is total voltage, capital V. Okay, that's it.